Hello, Assalamu alaikum, sir. It's me, Sijan Sharia Ananto. Our course is Basic Mechanical Engineering, and our presentation name is Classification and Brief Discussion about different types of air conditioning system and refrigerator. And my group members are the Mashur Islam Adib, Medha Chaudhuri, MD Shohanur Rahman, Nur Muhammad Mesbauddin Nahid. And here I go. What is air conditioning? Air conditioning AC is the process of removing heat and controlling the humidity of air in an enclosed space to achieve a more comfortable interior environment. The first air conditioner was invented in 1902 by Wills H. Carrier. What is refrigeration? Refrigeration is the process of removing heat from a substance to reduce and maintain lower temperature than its surrounding is called refrigeration. The term refrigeration means cooling a space, substance or system to lower and or maintain its temperature below the ambient one. How refrigeration work? There are four components in this picture. One is compressor, condenser, expansion valve, and four is evaporator. How compressor work? It works is to control the flow of refrigerant by acting as motor and a pump. This allows it to pressurize the refrigerant and reduce its volume. There are 5 types of compressor used in both commercial and domestic refrigerator. Second, condenser. The condenser work by condensing the refrigerant. The refrigerant entering the condenser is hot and pressurized. The condenser then cools the refrigerant by converting it into a liquid state. There are 3 types of condenser. One is evaporative condenser, second is water cooled condenser, third is air cooled condenser. Third, expansion valve. The expansion valve helps reduce the pressure and temperature of refrigerant. Fourth, evaporator. The evaporator absorbs heat inside the refrigerator. It acts as a medium of exchange for heat from the stored product to the refrigerant. Next slide. What is refrigerant? It is a heat-carrying medium which during their cycle compress, condense, expands and evaporate. It absorbs heat from a low temperature system and discards the heat to higher temperature system. A refrigerant is a working fluid used in the refrigeration cycle of air conditioning system. And heat pumps, where in most cases they undergo a repeated phase transition from a liquid to a gas and back it again. Next slide. How does refrigerant work? Refrigerant is a compound typically found in either a fluid or gaseous state. As refrigerant absorbs heat from indoor air, it transitions from a low pressure gas to a higher pressure liquid. The refrigerant then cools down and turns back into a low pressure gas. Another fan located inside the home blows air over the cool coils to distribute the resulting cold air throughout the building. Next slide. How refrigerant work? So, types of refrigerants. The most common refrigerants used for air conditioning over the air include 1. CFCs. This is known to contribute to the greenhouse gas effect. Second, CCFCs. Although slightly less damaging to the ozone than R12 was the EPA mandated a phase out with Clean Air Act of R22. Third, HFC. With no chlorine in the mix, HFC are safer for the environment. It's helpful for our environment. Next slide. Tons of refrigeration and how to convert into kilowatt. It is the quality of latent heat required to be removed from 1 ton of water of degree Celsius temperature to convert it into ice of 0 degree Celsius temperature within 24 hours. As tons of refrigeration is a unit of power, 1 ton equal 3.5 kilowatt equal 210 kg per minute. So my second group member MD Shohanur Rahman continue the presentation. Thank you.
Assalamu alaikum sir. I am MD Shohanur Rahman. I am the second presenter of our group presentation. Now I will describe factor affecting comfort air conditioning. The process of air conditioning in auditorium, office building, houses and classrooms is meant for maintaining comfort conditions for occupants. The 4 important factors for comfort conditioning are to be observed and maintained. These are temperature of air, humidity of air, purity of air and motion of air. First of all, temperature of air. The control of temperature means the maintenance of any desired temperature in an enclosed space even though the outside temperature is different. A human feels comfortable at 21 degree Celsius even though the outdoor temperature is varying. The indoor temperature is maintained to be constant, which is the desired condition. The heat may be either removed or added to the conditioned space depending upon the surrounding conditions. I think in these 4 factors, temperature is very important. If the surrounding temperature is less than the body temperature, the flow of heat from body become quite easy and normal flow. If this surrounding temperature is low, as in winter, the rate of flow of heat from the body is rapid and the person will feel cold. If the surrounding temperature is too hot, there will be no flow of heat. In such situation, sweat glands become activated. The moisture of body gets evaporated, which brings the temperature normal. If the outside temperature is hot and humid, little evaporation of moisture will occur from the body skin, and so the person will feel hot and uncomfortable. The movement of air by fan helps to keep body comfortable. When the room temperature becomes high due to the gain, it causes human discomfort. When the room moisture becomes high, the increased humidity causes difficulty in depositing the body heat for human comfort. In the indoor temperature of 20 degrees Celsius and relative humidity 60% in quite good. Any air conditioning unit will be able to achieve the above requirement and maintain the condition for comfort. humidity of air. The increasing and decreasing of moisture content of air during different seasons in order to produce comfortable and healthy conditions. A human being feels comfortable at 56% relative humidity. But in summer, relative humidity should be less than 60%. In winter, it should be more than 40%. Humidity control means an increase or a decrease in moisture content inside the space to be air conditioned. It is necessary not only for human comfort but also to increase the working capability in summer so the relative humidity should be 60%. In winter it should be 40%. Humidity also very affected factors, because if water is heated and it evaporates to the surrounding environment, the resulting amount of water in the air will provide humidity. Relative humidity is the ratio between the actual amount of water vapor in the air and the maximum amount of water vapor that the air can hold at their air temperature. Relative humidity between 40% and 70% does not have a major impact on thermal comfort. In workplaces which are not air conditioned or where the weather conditions outdoors may influence the indoor thermal environment, relative humidity may be higher than 70%. Humidity in outdoor environment can vary greatly and may be dependent on whether there are drying processes where steam is given off. High humidity environments have a lot of vapor in the air, which prevents the evaporation of sweat from the skin. In hot environments, humidity is important because less sweat evaporates when humidity is high. The evaporation of sweat is the main method of heat reduction. When non-breathable vapor impermeable personal protective equipment is worn, the humidity inside the garment increases as the wearer sweats because the sweat cannot evaporate. If an employee is wearing the type of PPE, the humidity within the PPE will be high. Now, purity of air. It is one of the most important factors for comfort. A human being might not feel good if the air is contaminated. So, proper filtration, cleaning and purification of air is very important. The factors which affect the air conditioning in addition to the control of temperature and humidity for human comfort. It is necessary to clean air, to make the indoor air free from dust, dirt and odor. It is necessary that proper filtration, purification of air should be done, and the supply of air free from dust and dirt should be made in air conditioned space. Now, motion of air. Motion of circulation of air is very important for equal distribution in the enclosed space and to keep constant temperature in the conditioned space. Air motion or proper circulation of air is also a factor affecting the human comfort in order to maintain constant temperature throughout the conditioned space. It is necessary that there should be equal distribution of conditioned air in the space. The air movement is maintained at the desirable velocity of about 8 meter per minute using appropriate distribution system grills etc. Now I am invite my next group presenter to continue this presentation. Thank you, sir.
Hello, my name is Mashur Islam Adib, and today I want to discuss to you about the four major components or parts of air conditioner. The first one is that I am going to talk to you about is the evaporator cell. And since there are many kinds of air conditioner, today I want to discuss to you about the split type air conditioner evaporator cell. The evaporator coil is found in the outdoor unit while in a central system. It is located in the air handler. Refrigerant which is flowing through the system is cooled to a low temperature just before entering the evaporator coils. As warm air from your home is drawn in your HVAC unit, it is blown over the cool evaporator coils which extract the heat and cool the air down. Fans located behind the evaporator coil then blow this cool air back inside, reducing your home temperature. The coils are usually made out of copper, but we can also use steel or aluminium, but copper is the most preferable one because it has better thermal conductivity than steel and aluminium, and it is easier to work with, and it can also be maintained easily. Be sure to keep your coil clean because as time passes, dust and dirt can build upon them and it will affect the efficiency of the cell. A build-up of this dust can also block the condensation drain and result in refrigerant leaks. While it is protected by the air filter, yearly cleaning will keep your evaporator coil in the best condition. Now the next part is the compressor. The compressor is the most important part of an air conditioner. The compressor is the workhouse of air conditioning. For central and split systems, the compressor is located in the outdoor unit. The majority of air conditioner energy consumption is because of the compressor, and it is generally the most expensive part of the system. So we can call it also the brain of the AC. The purpose of the compressor is, as the name suggests, to compress the refrigerant, which is a warm vapor as it reaches the compressor to a hot compressed liquid. As the air conditioning process continues, this is then cooled down and expanded again to remove heat from the indoor air. Based on the size of an air conditioner, the size of the compressor will vary. You can keep the most important AC component healthy by often checking for refrigerant leaks, preventing dirt and dust and contamination, keeping the condenser coils cleaned, and keeping your AC well oiled. The next part or component is the condenser coil. It is the opposite of an evaporator. The condenser coil pulls away heat from the refrigerant and ejects it to the outside environment. It is mainly located in the outdoor unit of your air conditioner. The evaporator coil works effectively in reverse to the condenser. With a fan with the fan blowing heat away from it, if you stand outside the outdoor unit of your air conditioner, you will feel hot air blowing out from it. This is the heat that the condenser is expelling during the process when changing the refrigerant from hot vapor to a hot liquid. The next part of the major component is the expansion valve. It is situated in between the condenser and evaporator. There is another little gadget called an expansion valve. As the refrigerant is now a liquid, it will be able to absorb the heat. In the expansion valve, the refrigerant expands into gas after facing a drop in pressure and is also rapidly cooled. This gaseous substance or cool refrigerant then goes into the evaporator coils to repeat the air conditioning process. In this way, four components work. Now we will discuss about how they function together inside an air conditioner. So at first, the refrigerant is compressed in the compressor and turned into a hot and high pressure liquid. This liquid flows towards the condenser coil and is cooled down with the help of a large fan. Next one is the expansion valve, which rapidly expands the refrigerant, converting it into a cool and low pressure gas. This cool gas is what cools down your room. That is done in the evaporator coils, and the coils get cold and a fan in the indoor unit blows the warm indoor air over them, turning down the temperature. So in this way the basic components of an air conditioner works. And now my group member Nur Mohammad Misbauddin Naid will continue from here. Thank you very much.
Hello sir, Assalamu alaikum. Welcome to my presentation. In this presentation I am going to cover the topic of function of 6 major equipments used in air conditioner. So the first point of the 6 major equipments of air conditioner is circulating fan. The main function of the fan is to move air to and from the room. The next point is air conditioning units. It is a unit which consists of cooling and dehumidifying process for summer air conditioning or heating and humidification process for winter air conditioning. My next point is supply duct. It directs the conditioned air from the circulating fan to the space to be air conditioned at proper point. So going to the next slide, as you can see, the next point is supply outlets. These are grills which distribute the conditioned air evenly in the room. The next point is return outlets. These are the opening in a room surface which allow the room air to enter the return duct. The last point of function of 6 major equipments used in air conditioner is filters. The main function of the filters is to remove dust, dirt, and other harmful bacteria from the air. So going to the next slide, the next topic of my presentation is the 7 categories of air conditioner. So the categories of air conditioner are actually divided in 3 ways: according to purpose, then according to arrangement of equipment, and the third one is according to season of the year. The first one I am going to actually describe is according to purpose. So the according to purpose, actually there are 2 kind of air conditioner available. One is comfort air conditioner conditioning system, and another one is industrial air conditioning system. So talking about comfort air conditioning system, the human comfort depends upon psychological and physiological condition. In these types of air conditioning system, the air is brought to the required dry bulb temperature and relative humidity for human health, comfort, and efficiency. If sufficient data of the required is not available, then it is assumed to be 21 degree Celsius dry bulb temperature and 50% relative humidity. In homes, office, shops, restaurants, theaters, hospitals, schools, colleges, etc. are using air conditioning system to give comfort to people. So these are the places where actually people use comfort air conditioning system, or as you can say, people use comfort air conditioner, or the comfort air conditioner are known for these places, for like schools, theaters, hospitals, restaurants, shops, office, and home. Actually people use comfort air conditioner in these places. So going to the next slide, as you can see from the pictures, these two pictures are actually comfort air conditioner. There are 1 ton or 1.5 ton, 2 ton, 5 tons, split AC and wall hanging AC there, as known as comfort air conditioner. This is a fronter and this is the outsider. So this is all about comfort air conditioner. Going to the next slide, I'm covering the topic of industrial air conditioning system. So what is actually industrial air conditioning system is? Industrial air conditioner systems are actually used in garments factories, mills like paper mills, and other productivity mills like electronic components and appliance used factories like motherboard, graphics card, or any IT sector, IT sectors units, building productivity units. Those are actually where the industrial air conditioner actually used, because to maintain the heat, because many people's work there in this industrial what is it called, industrial places. So in these types of air conditioning system, instead of dry bulb temperature and relative humidity of the air is kept constant for working of the machine and for the manufacturing process. Textile mills, as I have said before, the productivity units, productivity mills and factories like textile mills, paper mills, machine parts, manufacturing plants, then garments. There are very many types of garments industries are available where this type of industrial air conditioner actually applies. Tool room, photographic, etc. use this type of air conditioning system actually. So going to the next slide. As you can see from these pictures, there are three pictures actually. These are the pictures of industrial air conditioning system actually. There are exhaust fan here. As you can see from the below picture, there are 4 exhaust fan chamber here, which actually planted in industrial areas rooftops, and this pipe actually used in the a very common surface of inside the industrial factories, big rooms actually. So going to the next slide, another topic is according to season of the year. So there are 3 common air conditioning system actually available in according to season of this year, and it is winter air conditioning system, the summer air conditioning system, and the last one is year around air conditioning system. So talking about winter air conditioning system, the outside air flows through a damper and mixes up with the recirculated air. The mixed air passes through a filter to remove dirt, dust and other impurities. The air now passes through a preheat coil in order to prevent the possible freezing of water and to control the evaporation of water in humidifier. After that, the air is made to pass through a reheat coil to bring the air to the desired dry bulb temperature. Now, the conditioned air is supplied to the conditioned space by a fan. From a conditioned space, a part of the used air is exhausted to the atmosphere by the exhaust fan actually. So going to the next slide, as you can see, here is the diagram where every parts has been described by a diagram of winter air conditioning system. Here is a damper from where the actually air outside air flows here. After that there is a fast filter here, and second one is a preheater. After that there is a humidifier, half of a filter as you can see from the picture, the middle one, and air passes through it, and again reheat coil which generate actually it's changes the temperature of the air. And again here as the last part there is a fan, actually circulating fan, which actually spin, and all the airs through passes from this filter, preheater, then a humidifier, then reheat coil. It passes through this fan, and the fan actually pass all this air to the chamber of conditioned space. After that the air passes in circulated air, and in this way the circle actually works, and the air actually give a cold breeze. So that's how a winter air conditioning system works. So it will give a warm heat in winter based country like European many countries actually faces their temperature are less than -10, -2, -5. So these countries actually need this kind of winter air conditioning system. So I am ending my part here. My the next presenter is Medha. So thank you very much. Thank you, sir.
Summer air conditioning system. The outside air flows through the damper and mixes up with the recirculated air. The mixed air passes through a filter to remove dirt and dust and other impurities. The air now passes through a cooling coil. The coil has much below the low temperature in the conditioned space. The cooled air passes through a perforated membrane and loses its moisture, the condensed form. After that, air is made to pass through a heating coil which heats up the air slightly. This is done to bring the air to the designed dry bulb temperature. Year-round air conditioning system. A year-round air conditioning system should have equipment for both the winter and summer air conditioning. There can be so many combinations for providing year-round air conditioning. The arrangement of the combination such that one part should be working as winter and other in summer. Here, according to arrangement of the equipment, unitary air conditioning system. A unitary conditioning system comprises an outdoor unit including a compressor for compressing a refrigerant, an expander connected to the outdoor heat exchanger for expanding the refrigerant, a duct installed inside a zone of a building, a central blower unit having a heat exchanger connected to the outdoor unit through the first refrigerant pipe, and blower for supplying the air, blower unit including a heat exchanger connected to the outdoor unit through a second refrigerant pipe, and fan for sending the air, building for individually cooling or heating the zone. Accordingly, cooling or heating operation is performed on each zone of the building, and simultaneously additional individual heating or cooling operation can be performed on a specific space so that a cost can be reduced and cooling or heating in building can be efficiently performed. Central air conditioning system. Central air conditioning system circulate air through a system of supply and return ducts. Supply ducts and registers, that is cooled air from the air conditioner to the home. The cooled air back to the central air conditioner through return ducts and registers. To learn how central air conditioners compare to the other cooling systems, air conditioners dehumidify the air to improve comfort. However, in extremely humid climates, when outdoor temperatures are moderate, or in cases where the air conditioner is oversized, the air may not reach a low enough humidity to achieve a comfort level. In these instances, homeowners may reduce the thermostat setting or use a dehumidifier, but in both cases this will increase the energy used both for the dehumidifier itself and because the air conditioner will require more energy to cool the house. If you have a central air system in your home, set the fan for the auto and mode. In other words, don't use the system's central fan to provide air circulation. Use circulating fans in individual rooms. Conclusion: air conditioner is one of the most important innovation of modern science. It has made our life easier and has made possible to live in the most difficult weathers. Because of air conditioner, people can live in different parts of the world. How bad is the weather of climate? Thank you so much, sir.